Okay, in this next section, what we are going to talk about is overriding. So up to this point, we have talked about overloading a method, and overloading a method is when we um, have different signatures that are being passed into a particular method. And when the signatures are different, it basically finds the right signature and then calls that particular method. Overriding a method, on the other hand, is when we call a method with the same signature, but we have different code in that method. So think of it as kind of a identical code that we override. And it's primarily used in subclasses. So when we inherit a superclass method down, we can override that method and change the code all the way around and not even have to keep any of the code from the superclass. So, um, so we'll go ahead and take a look at in the book on page 641. And if you look, we can see that we have the graded activity. So we've seen that before. And now we have this curved activity that we're going to um, in, basically inherit the graded activity. And you'll notice that here we have a get score and it returns a double. And here we have get score and it takes in a double and basically passes back a void. So I'm sorry. Do we have get score? No, we don't. Do we? No. Anyways, so let's go ahead and take a look at the code, and it'll make more sense than your confused instructor here. So let's go ahead and look at it. So here we have the first. Let's take a look at the graded activity. So here we have, remember we had a score, and it's a double. We got set and get score, and then we have this get grade. Okay. Well, now we have this curved activity. So so basically here is kind of the scenario, and it says the graded activity that was presented earlier in this chapter has a set score method. But suppose the teacher wants a curve to basically wants to curve that score. The other one just does a straight set. But what if the instructor wanted to do a curve? Well, here's what they would do is they would create a curved activity. They would inherit. So here they extend graded activity. And then we have a constructor curved activity. Basically, we're actually bringing in a double percent, and we're saying percentage equals the percent, and raw score equals 0.0. So here's our raw score and our percent. So we go ahead and set those two instance variables. Then we come down here and we've got void set score. Now, set score is in the superclass, but in this particular case, we're basically bringing in a double S, and we're saying the raw score is equal to S, and then the super dot set score is raw score times percentage. So now I'm taking the super dot set score, setting it's just setting it. It's setting the score equals raw score times percentage. So we're still using the score instance variable. We're still using that, but this time we're taking the raw score and multiplying it times a percentage in order to set it. So we're basically overriding that particular method. So as you can see, the regular set score just sets a score in the superclass. In this one, we still use that set score, but now we're actually doing a computation. Okay, so and then we have get percentage and our get raw score. So basically we got our two getters there. So if we were to run this, and I believe this is the curved activity demo, and if I run this and I type in a raw score of 85, and the curve percentage we'll say is 7%, and so the raw score is 85%, the curve score is 595, and the exam grade is A. Okay, maybe I should have done that a little differently. Let's try it again. So raw score is 85, and the percentage is 0.7, and so the raw score is 85.9, and the curve score is 59. So exam grade is F. So maybe, so again, I don't use curve scoring or curve grading. I use just basically, so I don't really understand all that stuff, but realize it works. Okay, So if we take a look in the book and we go to page 645, 645 starts talking about overloading versus overriding. So if we take a look, it says, and there is a distinction between overload and and overriding a method and overloading a method. Recall from chapter 6, overloading is when a method has the same name but one or more other different methods with different parameter lists, so basically different signatures. Although the overloading method has the same name, they have different signatures. Okay, both overloading and overriding can take place in an inheritance relationship. You already know that overloading methods can appear within the same class. Okay, so if class A is a superclass, class B is a subclass, a method in class B may overload the method of class A or another method in class B. Overriding, on the other hand, can only take place in an inheritance relationship. So that's very important. Overriding can only take place in an inheritance relationship. However, a method cannot override another method in the same class. Okay? So it cannot override. So basically what we're saying is if I have a method called ABC with no parameters, I cannot have another method named ABC in the same class with the same signature. Won't work. But if I have an ABC in my superclass and I inherit it, I can then create another ABC class with the same parameters in my subclass, which will override the superclass. So just kind of basically talking about some of those different things there as well. So to kind of take this home, if we take a look at subclass 3, so here we have subclass 3 and we basically have it extends superclass 3 and we have a show value, and here is this is a method called show value. It's bringing in an int and it's going to go ahead and print out the argument is. And then we have show value, and there we have subclass, and it basically shows the value of a double. So it's going to show the value of an int or a double. Now if we take a look at the superclass 3, superclass 3 does the same exact thing, it looks like. We have a show value and a show value. One is an int, one is a string. So if we look at the show value demo main, so here we basically have a subclass 3 object equals new subclass 3. So we're basically creating or instantiating an object from the subclass, which inherits from the superclass. I say my object, since it's called my object, by the way, my object.show value 10, we're passing an int, my object.show value 1.2. Okay, hello. So let's again take a look at subclass. For an int is going to say the int argument is. For superclass, it's going to say the int argument is. It's going to say superclass though. Subclass is going to say subclass. And then we got double and we've got string. So again, if I were to run this, it says subclass, the int argument is 10. Subclass, a double argument is 1.2. Superclass, a string argument is hello. So the point there is this. Even though we have an int parameter int parameter show value in the superclass and the same thing in the subclass will execute first. Okay, it will not basically execute. So the overridden show value int basically overrode show value int in the superclass. So the subclass was executed before the superclass. Okay, so realize this was overridden from the superclass. It has the same name, has the same arguments, same everything. It was overridden with and the only difference between the two is this label right here. And since it's a subclass, it takes precedence over the superclass in that particular instance. Okay, so to continue on, if we take a look at page 649, 649 starts talking about protected members. And protected members, and we really haven't dealt with a whole lot. We've always talked about private and public. Well, this time we talk about protected. Protected members of a class may be accessed by methods in a subclass and methods of the same package as a class. So again, private, only that class. Public, anybody can get it. Protected, on the other hand, they must be within a subclass or within the same package. If they're within the same package, we have access to that variable. If it's basically part of a subclass and superclass, they have access to that variable as well. So if we take a look at grade activity 2, so grade activity 2, we have a set score double S, and we have a get score, and so we got our get grade. So it basically, I think it's identical to, take it back. It's not identical. We do have this as protected as opposed to being private. So now it's protected. That means it's opened up a little bit and it has access by some certain folks. And if we take a look at the final exam 2, so final exam 2 now has private int, num questions, points each, num missed. I believe we're pretty much the same thing there. And we got final exam int questions, int missed. So basically here is our constructor bringing in two ints, which is a signature, and we got the numeric score. And I think this is pretty much the same. Okay. So since it's protected, in the superclass, look at this. We have a method called adjust score, and it basically has a local variable called fraction. Fraction equals score minus int score. Where does this come from? Notice we do not have a score anywhere in here. It's coming from the superclass because it is protected. So if I were to go in here and change this to private, watch what happens to that particular method. We now get an error because we no longer have access to score. But if I come back over here and again change that to protected, that error basically goes away. So be careful with protected because it does open it up a little bit. But again, if we keep other methods out, other classes out of our package, or we basically just use our super and subclass, it should work just fine. So if I go ahead and run this, which I believe is the protected demo. And I run this guy and I type in how many questions. We'll say 105 or 202. How many questions student missed? We'll say 10. And so there we basically, so again, we're able to have direct access to that particular methods or that superclasses variable because it is protected as opposed to. So kind of another way to utilize those things. I'm not a big proponent of that. I would like to see us kind of use the setters and getters to basically utilize those instance variables. So okay, we'll go ahead and finish up in the next video lecture called Chain of Inheritance on page 655.